All right, we're going to be doing a calculus problem today. Calc BC, this is from the 2001 exam. BC free response number 6. Okay, a function is defined by that, and it says here for all x in the interval of convergence of the given power series. So their first question is find the interval of convergence for this power series, show the work that leads to your answer. Okay, anytime they ask you to find the interval of convergence, you have to have it set equal to a certain number. We want to use the ratio test. In this case, the ratio test is an plus 1 over an less than or equal to or less than 1. And you want the limit as n approaches infinity. So the key here is to locate your an, because once you find your an, you want to plug in n plus 1. Now, the concept behind this is very simple. If we have an infinite number of numbers just heading to the right, we want these numbers to start decreasing. An plus 1 is the next term over. If you take the next term, which is smaller, and divide it by the previous term, which is bigger, the idea is that the fraction should get smaller and smaller and what? Smaller. And so when you take the limit of this and you're trying to figure out where does it converge, well, we want all of this fraction of the next smaller term with the previous bigger term. When you put that in a fractional form or a ratio form, we want that, the absolute value of that, to always be less than 1. And that will guarantee that when you add up all of those terms, because it's getting smaller and smaller, it'll converge to a particular number. Now, if it's getting bigger and bigger, it'll obviously diverge, okay? Now, there's a certain amount of x values that this function or this function right here will diverge and converge. So we need to figure out what those numbers are. So let's utilize this. This right here, you should recognize is going to be your an, okay? Because that's basically going to define your next term over. So I'm going to write it right here. An equals n plus 1 over 3 to the n plus 1 x to the n. And then I need to define my an plus 1, which is just the next term over. So this would be n plus 1 over 3 to the n plus 1 x to the n plus 1. And then you need to put it in a ratio form, an plus 1 on top, an on the bottom, and do the math. Okay, so I'm going to put this on the top. So n plus 2 over 3 to the n plus 2, x to the n plus 1. And I'm going to divide this by an. So this would be technically an plus 1 divided by an. And the reason I'm doing it this way is so that I can just flip it for you. So this would be n plus 1 over 3 to the n plus 1, x to the n. Okay, so let's take that and flip it and multiply it. So we get n plus 2 x to the n plus 1 over 3n plus 2 times, and then 3n plus 1 over x to the n times n plus 1. Let's put parentheses around there. Okay, now we just have to simplify this out. So n plus 2 x to the n times x to the first power, 3 to the n times 3 to the second power. I'm just opening all of these up. And then times 3 to the n times 3 to the first power over x to the n, n plus 1. Now you realize there's a lot you can cancel out. Okay, so this right here will be just a number 3. This will be 9. And then remember, this must be less than 1 in the absolute value, and we want to take the limit as n approaches infinity. Now always keep this in mind. The key here is to determine x, okay? The radius of convergence or the interval of convergence, they're x values. The letter n, we're going to shoot that into infinity, okay? So let's write the simplified form out. So limit as n goes to infinity, and what do we have left here? We have n plus 2 times, we have, okay, I'm going to move the x, okay? I'm going to move that x right over here, and then times 3, and then I'll move the n plus 1 here, and this would be 3 squared, less than 1. Now, that's just 1/9. 1/9 is a number, so we can bring that out. So we'll put here 1/9. I'm sorry, 1/3. take the limit of let's see, n plus 2 over n plus 1 times x. Okay, so here, if I take n to infinity, these two will head to 1. The magnitude or the degree is 1. So the horizontal asymptote for this equation here will turn to 1. Okay, so this will turn to 1. And we're done. The limit of that is finished. So what do we have left? 1/3 absolute value of x less than 1. Multiply 3 to both sides. And now the absolute value of x less than 3 means x must be less than 3, or -3 less than x less than +3. This is your your interval of convergence, your IOC. However, we're not done because we have to plug in the endpoints. So the idea is this. Right now, the interval of convergence is from -3 to 3, or if you plug it into, if you use a number line, -3 to 3, and the center is at 0. Currently, we have this situation where everything in between, if you plug in these numbers into the function, it will converge. But the question is, what about the endpoints, -3 and +3? For that, we have to go back and plug it back in. And so it's going to take a little bit of work. Let's see. I'm trying to bring this down. So this would be n plus 1 over 3 to the n plus 1 x to the n. Okay, so so this is our an, right? Okay, so now because now we can plug in an x value, we're gonna first plug in x equals -3 and x equals 3, and then figure out if this series converges or diverges. Okay, so this will look like this: n plus 1 over 3 to the n plus 1, -3 to the n. And on this side, it will be n plus 1 over 3 to the n plus 1, 3 to the nth power. Okay, now this is actually pretty easy to watch. So if you simplify this, now you can use the ratio test again, but it's going to take a long time. You should be able to recognize that the negative can come out like this. And then on the bottom, 3 can be rewritten this way. Okay, 3 to the n times 3. So these two will cancel out. And you basically have an alternator, -1 to the n plus 1 over 3. Now, notice that we can use what we call the divergent test. Okay, divergent test simply means this: if you can take this and call this an AN, like a sequence, if you take the limit of a sequence as x approaches infinity, and it is a number or infinity, it's going to diverge no matter what. So we know if you increase n, the fraction will just get bigger and bigger and bigger. And yes, it's going to alternate, but it's going to alternate getting larger and larger. So this will definitely what? Diverge. And this one, I think it's the same thing. N plus 1. You can do the same thing, 3 to the n times 3, cancel those out. And yes, you can use this divergent test again. This will definitely head into infinity, or will just get bigger and bigger. So this will also diverge. So our interval of convergence is actually right. It's -3 to 3, open-ended. So any number in between will cause the function to converge. Okay, so that's how you work with that one. Okay, take a look at letter B now. Now this is actually not too bad either. Can I move this? Oops. Okay, so I'm gonna put it right there. So they're asking you to take the limit of this function, of this situation here, utilizing f of x, which happens to be this whole thing right there. Okay, now the ... means it's infinite. Okay, fine. Notice they want you to take all of that, subtract 1/3. Okay, so if you subtract 1/3, cancel, cancel. Everything else in between has an x. So you have one constant in the front, subtract 1/3. So you're left with all of these terms on the numerator. So you have something like 2 over 3 squared x plus 3 over 3 cubed x squared plus dot, 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 dot. And don't forget, you have to divide by x. Now, let me just kind of back up a little bit, because when you find the limit of any function and it heads to 0, the first thing you want to try is just plug it right in. So you plug it in and you realize the denominator equals 0. And that's when you realize you have to do some factoring and canceling out, rearranging or simplifying, because your goal is to find a way to plug 0 in. And ultimately, after all of that, if you can't plug it in, most likely it's just undefined, okay, or divergent. So right now we can't plug it in because there's x on the bottom, but you realize when you have a polynomial on top divided by one denominator, each of those terms can be divided by the common denominator. Now, for those of you, if that doesn't make sense, let me give you an illustration. If you have something like 4 plus x plus y divided by, let's say, 2, okay? You have a polynomial on the top. You have one denominator. You can use what you call partial fractions. You can split this up into fractions with a common denominator, okay? Now, we're normally used to going this way, right? The teacher always tells us to combine it, but we need to be able to go the other way as well. So take that, and you'll notice the first term, it will cancel out. But the terms afterwards, because their exponents are bigger than 1, you might cancel the exponent, but the letter x stays there. So that means every term after 2 over 3 squared has an x, or some degree of x. So if you plug in 0 into all of that, the only number left behind that's alive is 2 over 9. And that is the answer to letter B. Excuse me. All right, and then number 3. Let me bring this down because I need to see this again. So it says here, write the first 3 non-zero terms and the general term for an infinite series that represents the antiderivative from 0 to 1 of f of x. Okay, the first 3 non-zero terms, that's basically these guys, 1, 2, and 3. And then the general term is all of this stuff, okay, the dot, 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 right? Okay, all they want you to do is take the antiderivative of this function. Now we're going to be taking the antiderivative of this infinite series. So technically you have this, you're going to take the antiderivative infinite amount of times. Let's do it. So antiderivative of f of x. So what's the antiderivative of 1/3 with respect to x? Well, here we should write something like, let's do that. So let's just write it down appropriately so that the test proctors will give you the full credit. So you'll do that. 3 cubed x squared plus dot, 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 n plus 1 over 3n plus 1 x to the n. And I'm going to put here dot, dot, dot with the parentheses dx, okay, and from 0 to 1. So that's how you want to write it. You always need to have a dx because it'll tell you which letter you're taking the derivative, the derivative of. Okay, so very good. So the derivative or antiderivative of 1/3 is simply 1/3 x. And then you have 2x squared over 3 squared divided by 2. And notice that the 2's will cancel out. 3 over 3 cubed, x cubed over 3, because you add 1 and you divide by that exponent, plus dot, dot, dot. Same thing here. N plus 1 will stay the same. 3 to the n plus 1 is kind of like the coefficient. The x variable gets n plus 1 divided by the same exponent. And there it is. And then you just go plus dot, dot, dot. And you want to take this with respect to you want to evaluate this from 0 to 1. So what does that mean? Well, you have to go back and plug 1 into all of this equation and then subtract 0 plugged in to all of these numbers here. So if you plug in 1, you'll get 1/3 times 1 plus, and this one here will be 1/9 plus, let's see, that the 3's will cancel out, 1/27 times 1, or 1 to the 3rd power, and then plus dot dot dot, and this will just become n plus 1 over 3 to the n plus 1 times n plus 1. If you plug in 1 right here, it'll just be 1 to the n plus 1, which technically just equals 1. And then you want to subtract all of this with 0, but you want to plug in 0, but if you notice, since every one of these has an x variable, if you plug in 0, every single of these terms will just become 0, and there you have it. This is what they want, okay? Or just the 1/3 part here. And yeah, you can simplify that on your own. Okay, and then lastly, so let's see. Let's take a look at this function. This sequence. I'm sorry, this series plus dot 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 dot. Okay, you should be able to recognize that this is a geometric sequence or a geometric series. A sequence is simply a number pattern. So it's like 1/3, 1/9, 1/27th, and you realize that the ratio is 1/3. You just multiply. So R is equal to 1/3. A sequence is simply a number pattern. A series is basically the number pattern with all of these plus signs in between. You're trying to add it all up. Well, it turns out that if it's a geometric sequence or geometric series, it's easy to add it up. You just use this formula, the sum of all infinite numbers if it's a geometric sequence. Now there's a trick. There's a condition. R must be between 1 and -1, or the absolute value of R must be less than 1. And we have that. R is 1/3. You just multiply 1/3 all the way through. So it's the first term, A1, divided by 1 minus R, and that's it. What's A1? A1, the first term is 1/3, which is right over here. So 1/3 divided by 1 minus the ratio is 1/3. So it's simply 1/3 divided by 3 over 3, 2/3, and just flip it around. So it's 1/2. And there you have it, folks. Okay. All right, I hope that helps.